I asked you to demonstrate how GPS works on a flat Earth. You agree GPS works?
Is GPS closed source or open source?
What does that matter?
GPS is open source technology.
Why does showing if GPS is open source or not change the whole argument?
No clue.
Alright, so let's talk maps. Just to make it simple, if you take a globe and you flatten it from the bottom up, you're taking things in the southern hemisphere, which should be close to each other, and you're actually making them wildly far apart.
When we go to the south, we have to make huge magnetic declination corrections to be able to adequately navigate. They traveled in the south back in the day, assuming a sphere. They consistently got lost. It didn't work. We had to make gross corrections to them. So that's the unspoken truth here. And no one wants to talk about. The south is not the same as the north. It should be exactly the same.
For some reason, even though I've got like this special account, I've got a gold account with Flight 24, it will never give me the GPS altitude, the true airspeed, or the indicated airspeed. However, if I go up and find a flight in the north, all of a sudden those numbers show up.
Well, those are the corrected numbers.
Oh yeah, okay. Because it's corrected because it doesn't fit your particular ideations.
Yeah, the real life. You're right. Everything you guys do is a correction because it doesn't fit real life. I appreciate that admission. Next.
Exactly.
And explain to me why it's hidden by the United States government.
You don't have access to the ground speed.
That doesn't make sense to me.
This isn't public accessible information.
At all.
It makes no sense.
It's just a GPS space. It just tells you where you're at.
Why is he asking? You asked him, how does GPS work if the Earth is flat?
Yeah.
How has the conversation gone from you asking that to you having to prove whether GPS is open source?
If it is changing things and telling people to adjust for the globe, then we would not know that, and they would hide the GPS source code, which is exactly what happens.
Government protected data.
So give me that source code and I'll be able to tell you all the transformations that they've made from the real Earth to the globe Earth.
I don't have that, obviously.
All of the flight times match what we expect them to.
Coordinates work.
Based on corrections.
Nothing is out of the norm.
See this again, you leave yourself open for deception so easily. What if let's just say planes can go faster than we're told. Hold on, let me just ask you a question. What if planes can go faster than we're told?
What are they going to burn?
Nothing. Ultra high pressure compressed air.
Whoa. Just air? How fast are we talking? 0 to 60.
How fast do you want to go? They have a pump.
Really?
Yeah.
So it gets it from the outside?
Yes.
Wow.
You want to go as high as possible. Yet at a high altitude, the energy you use in cruise is very low. So you really don't need any kind of reserve fuel, if you will. Like, the way to think about a plane is it's a force balance. Now, the higher you go, the lower the air resistance is. Air density drops exponentially. The higher you go, the faster you will go for the same amount of energy. And at a certain altitude, you can go supersonic with less energy per mile, quite a lot less energy per mile than an aircraft at 35,000 feet, because it's just a force balance.
So imagine that I've got a little 2 toy cars that I'm starting in New York, and I want one to get to San Francisco and one to get to Colorado. Could I program them so that the one gets to Colorado after the one gets to San Francisco? Is that possible?
If you vary the speeds.
Right. So by varying the speeds of planes, you could easily get them where you want them to be at a certain time. And you're here telling everybody, because the plane gets there in the amount of time that we expect on a globe, that's evidence or proof of a globe. Do you understand that you're opening yourself up for deception? Your idea of scrutinizing the evidence is to look at the flight times, and once they match what you expect on a globe, you consider that evidence.
You had to appeal to these jet streams just to cover the distance in the right amount of time.
Correct.
Okay.
But then, by appealing to that, the return flight, which doesn't have the jet streams, because jet streams don't magically change direction.
They absolutely do. They absolutely
I told
do.
you that we're like 5 steps ahead of you.
Yeah, they absolutely
that?
do. I can bring up paper after paper that says it. Now, they don't tell you that today. You actually have to dig in. You can't just do cursory, go listen to Professor Dave videos. That's not the way you get research done.
Provably, the jet streams can go in completely opposite directions, just at different altitudes.
Yep, and just 1,000 feet higher.
Altitude, and then just interior of the other one, it goes the opposite way. And we have it mapped out right here. We can show the entire audience.
Do you see jet streams going both directions here? Do you see a jet stream going this way and a jet stream going this way?
Yes, I do.
Okay. So there's jet streams that go both directions, and the planes know this. How do they know? Because they let up balloons, 2,000 of them every day. They get all this wind data, all the cloud data, and then they program it into the planes, and the planes get where they want to go at a certain time. Imagine how everything would fall apart if one plane arrived late, and then everybody on that plane misses their connection. It would be a disaster. But we don't have that. For the most part, planes get where they're going on time. For the most part.
And I'm asking you, are they consistently going different speeds? Jaron just gave you the logical answer for it. And when we start to go from continent to continent, they assume the Earth's a sphere, therefore they have distances to these places, and then they have a certain schedule, and the plane's engineered to match the certain time it needs to. That's how it works. They go faster and slower all the time.
You're a man of economics, you said, right? So if I can show you that a plane is going way too inefficiently, way under the speed it can go, why economically would you ever go so slow? A plane is terribly inefficient at 250 miles per hour. A jet.
Yeah, I don't know why a plane would go slow.
You got a 300-mile difference, but you're saying they're within minutes of each other. So how is the plane doing that?
So you're saying one's traveling way faster than the other one, right?
Well, hold on for a second.
Right, I didn't know planes do that.
Yeah, they don't. That's the thing. But they have to in your model because you're going a distance that's making it go 500 miles per hour. But we know that the jet stream is 250 miles per hour. So they're actually going 250 miles per hour less.
Yeah, so either your model's correct and the plane is slowing down.
Right.
Or our model's correct and they're actually just optimizing speed, which autopilot does automatically with air resistance. And we see the same thing with the world record of the sailboat races, where the world record speed in the south is way slower than in the north. Why is that? Because they're actually going further than they think. They're calculating speed based on that equation of speed equals distance over time, assuming a globe distance, and it's taking them way too long to get over a short distance, so they get a much lower speed. What a recurring theme that's such a coincidence that things just decide to go way slower in the south. Like, well...
Well, I'm just asking you why you accept sailboats in the south for certain things that you like, but you don't accept the ones
What don't I not accept? You're claiming I don't accept something. What don't I accept?
That people circumnavigate around Antarctica with their
Yes, they
sailboats.
circumnavigate the Earth. Yes.
No, they go around Antarctica like this. They don't
Correct.
just go around a perimeter of a circle.
What would be the difference?
Distance.
Yeah.
And we're giving you evidence.
So those boats that go around, they do their whole little trip, they get back, they do the calculations, and they come out that they were doing 4 knots.
Yeah, so what? Maybe there were stronger winds. There's going to be periods where your boat's not even moving.
Okay? 4 knots. For the world record of going around the southern hemisphere, when the boat, go look up the boat does 35 knots.
Not all of the time.
Guess what? There's a current that goes west to east of 2 knots. So how is it that boats magically slow down to 4 knots? And it'd be like me telling you I broke the world record for driving a car. Be like, really? How fast did you go? Be like 45 miles per hour?
Cars have engines. That's very different.
You'd be like, what are you talking about? Cars go way faster. And I go, well, they didn't in my race. My race, I won at 44 miles per hour.
Wait, look, here's the world record in the north. It's going 220. And you're like, no, but dude, I set the world record in the south. It's 45.
They're also not going 32 knots the entire time.
In our paradigm, the south is way bigger, right? And what a coincidence that the world record of the boats is way faster in the north than in the south. But it would make sense if they assume a globe. So they assume a symmetrical distance in corresponding northern and southern latitudes, right? And so then they do their little race. They assume that distance, and then they're taking way longer to do it. And they're like, what's going on? That must mean we're going way slower. Or they're actually going fast, just like the boats always do, but they're going further than they think they are. And so they assume the shorter distance of the globe, and they get a shorter.
And we only believe this
speed.
because there's an accumulation of evidence like this, the undersea cables. Why is it that the undersea cables do not cross the Southern Ocean?
Because the sea cable's positions depends on what is needed and the countries that put them down and things like that. It's a lot harder to put cables underneath the entire ocean for that big distance than it is to just go up along the coast of the Earth.
We took this and bent it flat Earth map. Well, if you did that, you wouldn't break any of the undersea cables. They'd all stay attached. So there's no cables. The planes go way too slow. Why is there no cruises that go South America to Australia, South America to New Zealand? Why is there no cruises? And the reason why is because you would find out real quickly that that's a farther distance than your told.
Guys, I want to talk about Southern Hemisphere flights. I don't want to talk about cruises.
But hold on, a flight, we would agree that a flight can move faster or slower, right? Planes can go faster or slower, and a cruise ship really can't. A cruise ship's pretty much 20 miles per hour tops.
All right, let's
so you just want to ignore that. Ignore that there's no cruises. I guess we can't find any cruises. People want to go to Australia, to South America. They don't exist.
Look, I'll be the Glover. So, we know that the Earth can't be a flat Earth, right? Because we have continuous flights. We have continuous flights in the south, from southern continent to southern continent. And if for that to be on a flat Earth, and then they'll usually strawman the distances or the past, whatever, like the plane would have to go however fast, and they always actually exaggerate those numbers. But anyway, so there's no way that could possibly happen, because planes can't go that fast, and we know that, and it would have to go 1,300 miles per hour on a flat Earth, or something like that. Okay, and now this is the reality. It isn't anything like 1,300. You can look at it, break it actually down. It's roughly around 900 to maybe up to like 1,000 or so. Is like where it really tops out when you do everything properly. But this is what's so funny. Whenever they go look to debunk it, we know the planes don't go that fast, right? And then I'm like, oh, how do you verify the distance? They don't know. And then I have to tell them, like, speed equals distance over time. How do you verify? You know, we have to go through a whole equation of speed equals distance over time every time. So goofy. But this is the point. The program that they use, right, that says, like, okay, the plane's going this fast. It shows the same speed both ways, but different times, but the same distance. So speed equals distance over time, but it's showing different times, same distance, same speeds. So what it actually proves is that it doesn't work on the globe. Whatever they're doing isn't happening on the globe. It's something more like what we're saying. For sure, the data that they invoke that says, oh, but the plane's only going 550 miles per hour, can't be true, because it wouldn't allow it to work with the distances and times that are actually claimed by the globe. And that's why I love to expedite the combo to that part, because where are you going to get your ground speed? Where are you going to get your airspeed? Airspeed is actually determined relative to the static pressure around the plane. It's difficult to get ground speed. Let's figure it out. Because in the north, we found out planes have been clocked going like 850 ground speed, right? In jet streams in the north, and they're known to be faster in the south. No one admits they're faster in the south, and admits they can't even fully measure them in the south because they're so tricky and it's so difficult to measure them. So long story short, the data that, like, say 24/7 flight radar and all this stuff that people say, oh, this proves that the plane's not actually going that fast. It doesn't. It actually assumes a globe distance, right? It gives you the time difference, but then it gives you the same speed both ways. Which means provably that data can't be correct. The data cannot be correct. They can't be going the same speeds, right? Because if they're going the same distance, but it's taking different times,
they must be going different speeds.
History is important. So if you don't know how these things came to be, you are probably going to start to believe blindly. So this is why we know the difference between airspeed and ground speed. This is why we know that the ground speed is protected by government data. This is why we know this coordinate system is fictitious, need corrections, and cook the books in order for it to be implemented over a plane to convert to a globe. We know this already. We know about magnetic declination. We know about the correction tables. The question is, do you?
Not everybody can be a robot polisher.
Like, would you agree that if you attain the ground speed and it was different, then that would mean that there's something weird with the coordinate system? Would you agree with that at least? If you attain the ground speed and you did the calculations based off of a ground speed relative to an airspeed, all the calculations will be different.
Yeah, but the question is...
Right, bro, then that's all we need to know. I'm going to let you finish, but I'm just saying that's all we need to know.
Why does showing if GPS is open source or not change the whole argument?
No clue.